experiment time. I want to find out if it does actually work when you get a zinc-air cell and you stick a resistor across it and put it into a very small enclosure with very little access to oxygen and see if it does generate hydrogen, push this out. And the only way I can think of sealing these up properly, because the hydrogen is it's a very small molecule and it will find its way out of just about anything. So the way I've thought about doing it is to actually melt the ends of these syringes after I've pushed the plunger in as far as it can go. And you can see this seals really well. We can actually see it clouding in the end of that when I tighten that up. Pretty impressive. And it pings back out. I'll also maybe put a wee wipe of silicone grease around these just to try and make a better seal. So here's what I'm going to do. Here's one of the cells. Instead of completely peeling its little label off, I'm going to put a resistor in and then put the label back down just to hold that resistor in position. It's a 270 ohm resistor. So that's now clamped back down in that, and I'm going to fold it up like this, maybe pull it out a little bit more so it can fold up. Keep it as small as possible, and then I'm going to fold the top across and use a bit of heat shrink to hold these in place. So I shall crop these wires down with a pair of side cutters and make sure I don't short it out completely. I think it'd probably still work, but you know, I want a scientific experiment here. I want to control the current. Then I shall put a bit of heat shrink sleeving across it, like this, and grip it with a pair of ceramic tweezers to protect my fingers, and then shrink it all down so it holds the connections in place. I really should zoom down this, shouldn't I? This would be better, so we can get a better shot of what's actually happening here. So I'm going to grip this. I'm going to get the hot air gun, and I'm going to shrink this down so that it grips everything into position. Hopefully. Sometimes you find with the heat shrink, once it cools down, it sort of relaxes a little bit again. So hopefully that will be holding those. We can measure across the resistor and find out, and see if we have voltage across the resistor. So there's the first one. Let's bring the meter in and see if we've got voltage, which won't be very high. It will be something like 0.4 volts or less. Touch it to there and to there. Yeah, 0.6 actually at the moment, because it's had a wee burst of air. Right, tell you what, into its syringe it goes. It'd be nice if it went always like that. Oh, it is. It's going to fit. Right, tell you what, a bit of grease, silicone grease. I shall just rim it and plunge it in. Get that to sit down. Sit down. No, it's decided not to sit down now. Oh, what a nuisance. Lie down flat. There it goes. Now I'm going to put this in, give it a wee squish around, push it right down to the point it's virtually touching that cell, which is just refusing to stay flat. This is what happens when you're experimenting. Nothing ever goes to plan. Stay flat, cell. Goodness sake. Bloomin' heck. Yeah, that is not going to plan. I want to squeeze as much of the air out as possible. Let's see if I can drop it in like that. It's down. Push this down, and then we'll bring the heat gun in again, and we'll heat the end of this up until it starts to melt. And then I shall pinch it together with my bare fingers at the risk of burning them in the process. This is I've tried it before on that other syringe, and it goes kind of glass-like initially. It goes very clear. And once it's gone clear, I shall just pinch it. It is a bit like glass, but it is plastic. That is it pinched. Righty-ho. So that should be sealed now. And theoretically, if that does generate hydrogen, it will push this plunger out. Right, okay, here's the next test, is this other cell, which maybe I should cut a small bit of tape. Maybe I should get the silicone grease off my fingers, he said, wiping them in his pants, which isn't necessarily the best thing to do. Right, tell you what, I shall peel this tape with this one and do the same again. I put a bit of Captain tape over this just to try and keep it protected from oxygen for this experiment. So this is an actual cell that came out of a air freshener that uses the gas generation to squirt its stinky schmoo out. So let's fold this up, put it across like that. Oh, it's trying to get out, it's trying to escape. It's okay. I'll shove it back in. And I shall crop that there. Get another bit of heat shrink across it. I'll just leave the Captain tape full height here. Maybe I'll just grip the resistor with the, this is a good idea. It's probably a terrible idea. That could also do with being just pushed in a little bit more at the bottom. I'm just rambling here, just why this is experimental. I'm just making it up as I go along. This is how you experiment. This is how stuff gets designed. So that should be shrunk down suitably. If you're thinking that the shrinkage of the heat shrink is going to stop the gas escaping from the little holes at the back, it will find its way out. It will push its way out, particularly around that resistor lead. So let's test round this one. So, am I getting voltage? Yes, it's actually because I've exposed to air, the voltage is shot up in this one. Not convinced that's going to make the best connection there, but hey, it's an experiment. This is where I could have done with cutting that. It might not end up going down so easily long ways. Is it going to? What if I use the tweezers to tweeze it in? I may have to trim some of that heat shrink off with a sharp knife. Oh, sharp knives. I have blunted all my knives, so you excessive violence. Oh, that is so blunt. It's just basically trying to pull the heat shrink off. That's no good. I really need a new blade. I've been cutting tarry felt, and that's very abrasive. It's got the grit all over it, so it's wrecked that blade completely. He said poking the blade as if to prove the point. So let's pop this down here. Try and get it to lay flat, as before. Moosh. Then I shall put some grease in this one. And put it in. And heat this one up as well. And this is a real gas generating cell, so it should do something. Or maybe neither of them will do anything. Time will tell, and really it is time. The next bit of this video is going to be some time hence. Maybe days hence. Because I'm not sure how long it will take for it to start doing it. I think it has to use up available oxygen first before it can actually move on to generating the hydrogen, if it even does generate it. Pinch that shut. Oh, that's very hot. Yes, indeed, that's working. Fingerprints now imprinted. So there are our two syringes. Now all we need to do is wait. So, well, basically speaking, one moment, please. Progress report. Movement has been detected overnight. And approximately 4 days later, the syringe with the hearing aid battery in it and the 270 ohm resistor has produced approximately 10 milliliters of gas. I'm not sure what it is. It's supposedly hydrogen. I have a naked flame here to test that. We shall test that. The one with the battery out of the, well, the gas generating cell, out of the air freshener, has not achieved the same amount of gas. But having said that, to do this test properly, because hydrogen is a very small molecule, it finds its way out through any crevice. Even though I put silicone grease in these, there is a risk that maybe some is leaked out. To do the test properly, I'd need to put maybe 2 or 3 of each cell in separate syringes so that I got an average across those syringes. Meanwhile, the grease dispenser, I replaced the batteries in it with a couple of zinc-air cells. And because I completely broke the resistor, I replaced it with a resistor across it. And it's interesting to note that because there was already an air pocket in there and I'd had it open, it kind of didn't do anything for a while until it consumed all the oxygen in the air, and then it started producing pressure to push the grease out with a plume. So interesting that these things you really need to try and put them in as small a space as area, as I did here, so there's not too much air to interfere with the operation, because it is the starvation of air that seems to make it do this thing. Okay, now comes the flame test. This is hydrogen, so theoretically it's lighter than air. It kind of popped and it blew the flame out. A bit of an anticlimax, but then that's because it's pure hydrogen and not oxygen as well. But you can see the steam in here, it has burnt. So that was combustible. So let's just say that was hydrogen, and this is silicone grease. Right, I'll just pop that right back in there. Actually, you know what? Oh no, I can't do that anymore, because now I've broken the seal on it. But there we go. It does appear that standard zinc-air cells can be used to generate pressure in confined spaces in a very controlled manner just by putting a resistor across them. Particularly when, definitely when you starve them of the oxygen they need, because then they do that other thing that they produce hydrogen instead. I'll put a link to Abe's video. Abe has been experimenting with this as well, Arduino versus Evil. But so far, this is a very interesting thing. It's something I wasn't really expected to be so simple. And the odd effect of a standard zinc-air cell that has this other function of producing a reasonably high pressure gas at significant enough volumes. Some of the manufacturers that make, Varta, claim that one cell of their special gas producing cell will produce about 150 milliliters of gas. Very interesting, well worth exploring.